Converse of midpoint theorem. The line drawn through the midpoint of one side of triangle parallel to the another side bisects the third side. The line drawn through the midpoint of one side of a triangle. So here is a triangle. I can say it A, B, C. Okay, so this is a triangle. A line drawn through the midpoint of one side of triangle. One side of triangle, it is the midpoint, and drawn from that side parallel to another side. So this line is parallel to this side, and it is also E is also the midpoint of AB, a triangle in which a side is drawn which is parallel to the third side of triangle, and E is the midpoint of AB. Okay, so parallel to another side bisect the third side. This bisects. Okay, we have to prove that the line drawn through the midpoint of one side of a triangle. Let us consider one side of triangle AB, and E is the midpoint. Okay, and parallel to another side. This is parallel to another side. Bisects the third side. Here is the third side, and it bisects it at that point. So it's a triangle. We have three sides, 1, 2, 3. A line is drawn which is parallel to this side. So I have drawn a line which is parallel to this side, and this point is midpoint of this side. I have to prove that this is the midpoint of this side. Clear? So here is the diagram ABC in which EF is drawn. So let's start. Given triangle ABC where E is the midpoint of AB. I have a triangle ABC where E is the midpoint of AB. F is the sum point on AC. F is sum point on AC. E is the midpoint of AB, and F is the sum point on AC. Okay, and EF is parallel to BC. It is given. EF is parallel to BC. EF is parallel to BC. And to prove F is the midpoint of AC. F is the midpoint of AC. So this is the statement of the theorem. This is the given points. These all are the given points. And to prove, if you write only these steps with diagram, you will probably get 2 marks out of the theorem. Okay, so let's start construction. We have to do construction. So first of all, through point C, draw CM parallel to AB. Through point C, let us draw CM parallel to AB. CM parallel to AB. Extend EF, and this point is F. So extend EF, let it cut CM at D. Extend EF, let it cut CM at point D. Okay, so here we have a triangle ABC. By construction, we are going to extend CM, which is parallel to AB, and we are also extending EF to point D, where EF cuts CM at point D. Okay, now proof. In quadrilateral ABCD, clearly we have a quadrilateral EBCD. EBCD is a quadrilateral. It is a quadrilateral. So we are going in that quadrilateral to get the desired result. So ED is parallel to BC. Clearly ED is parallel to BC. If EF is parallel to BC, if EF is parallel to BC, then surely ED is also parallel to BC by construction. Okay, so in quadrilateral EBCD, ED is parallel to BC because EF is parallel to BC. It is given. So by construction, we can say that ED is parallel to BC. Clear? AD is parallel to BC. Similarly, EB is also parallel to DC by construction because opposite sides of a quadrilateral are parallel. So this one is going to parallel with this side and this is going to parallel with this side. Since both pair of opposite sides are parallel. Since both pair of opposite sides are parallel, so EBCD is a parallelogram. Clearly, EF is parallel to BC. It is given in the theorem, that is, we can say we proved there that EF is parallel to BC, parallel to the another side. So if EF is parallel to BC, then ED is also parallel to BC, and by construction we did that if AB is parallel to CM, AB is parallel to CM, then EB is also parallel to CD by construction. So clearly, if opposite sides of a quadrilateral are parallel, so the given figure is parallelogram. So the given figure is parallelogram. Now, since opposite sides of parallelogram are equal, clearly it is a parallelogram. Then the opposite sides of parallelogram are equal. So EB is equal to DC, EB is equal to EA, EB is equal to DC, and also EB is equal to EA. Opposite sides of parallelogram are equal, so EB is equal to DC, and also AE is equal to EB. This is given because the line drawn through the midpoint of one side, so it is a midpoint, so clearly AE is equal to EB. So here I have EB is equal to DC and EB is equal to EA. EB is equal to EA because he is the midpoint of AB. So I can say that these two lines are also equal. That is DC is equal to EA. So this is my first equation. This is my first equation. Also, EB is parallel to DC. EB is parallel to DC. If EB is parallel to DC, then AB is also parallel to CD. If EB is parallel to CD, then AB is also parallel to CD by construction and with transversal ED. What is transversal? Transversal is ED. Transversal is ED. These two lines are parallel and this is the transversal. And if it is the transversal, then angle AEF, this one angle AEF and angle CDF, AEF, that is AEF and CDF are alternate angles. AEF, sorry, this one, this is not the angle, this is AEF, this one and this one, FDC or CDF. These are the pair of alternate angles. These are the pair of alternate angles. This one and this one are the pair of alternate angles. Now we are moving in triangle AEF and triangle CDF. In triangle AEF and triangle CDF, AEF and triangle CDF, this triangle and this triangle, this triangle and this triangle. So let's move on. Angle AFE and angle CFD. So I'm going to create that triangle there, which name is AEF, and D, this one is DC. Okay, so DC. So these are the pair of vertically opposite angles. Angle AFE and angle CFD are the pair of vertically opposite angles, and angle AEF and angle CDF, these are the pair of alternate angles. Also AE is equal to CD from 1, which we proved there. Okay, so by angle side, SAS rule. Okay, I can say that triangle AEF is congruent to triangle CDF. AEF is congruent to triangle CDF. So whenever we make two triangles congruent, then we have a magic stick which says that all the sides as well as angles of corresponding triangles are equal. CPCT is the magic stick, that is a corresponding pair of corresponding triangles. All the sides and angles of a triangle are equal. So by CPCT I can say that AF is equal to CF by CPCT. If they are equal, that means F is the midpoint of AC. F is the midpoint of AC. This is, we have to prove that, hence proved. So it is the converse of midpoint theorem.